to be on your terms. So even if it's a metamaterial, the things that you guys are trying to communicate from that are important. So, study of porosity. What exactly are you studying?
Like so far we looked into hydrogel. Like this is the most that we thought that yes, it captures and yes, it retains water.
Yes.
And for like at the same time, we're trying to research lightweight materials that
Right.
okay, it still floats while it absorbs, and so it's just this is just a beginning of a study that would eventually lead up to this whatever material this is that is lightweight, because so far you know with hydrogel taking in much water it weighs down, right?
Right.
And
I mean, the only point that I'm saying is like, so for example, when I'm listening to you speak, uh, it goes back to the fact that we're looking for a material, but actually, that's not what we're doing. And I'll tell you why. Because you guys said our system is hybrid and our system will be exploring multi-materiality. So I don't think it's an issue of trying to select materials, but it is an issue about, let's say, for example, not understanding porosity by itself, because in this definition of porosity, it just basically means, you know, openings for water to be captured. You're talking about, yes, you're talking about water pellets, and yes, you're talking about rain, but yes, you're also talking about air. And the porosity level for extracting out of air is means something very different than, you know, water harvesting off of a surface of something that's already condensed, or something that maybe is ice or hail. So I just mean, like, in the concept of what you guys are doing, there's a concept of harvesting and its relationship to porosity, I think, is important. But I also think like hydrogel is one material behavior, but for example, the textile was also being demonstrated as something that was super light and surface oriented. And the thing that we said originally was like, it's pretty straightforward to understand, like, okay, the surface as a technology and that prototype is phase changing. You know, it's a trigger for phase changing, but it's not the water retention, right? It dribbles into a pot and then people take the water from it. So if we wanted to develop a strategy where the skin is also where the water is retained, for whatever scenario that we're doing, we said we would have to design the pockets of where hydrogel would be. And let's say you take that as a study. It was like saying that this is what you do, but I'm just saying this is one experiment you can do. Wherever you locate the hydrogel is basically where you want to channel the water to, right? So if hydrogel is everywhere, like in this simulation, if the hydrogel was located at the top of the project, that's the part which would swell and it wouldn't allow any water to get in to the lower levels, right? Because it's basically, hydrogel is a reactive kind of thing. It's going to absorb the water at the source. If the hydrogel was at the bottom of this thing, it would also change the volume at the bottom. It would be weighted at the bottom, and it would say that this first stage is filtering through. And you can imagine when the bottom ones are filled, all what happened was that they would continue to fill because we would have a new ground, basically. The bottom ones would be completely saturated. The top ones now would be the new ground. And why am I saying that's important? Because that's different ways of interpreting this concept of porosity by adding one variable, which is where is the location of the water retention aspect of your materiality, and it changes the implications, right? So porosity that can actually move through the system is advantageous because then we build up in this particular sequence ways of affecting as many hydrogels as possible. If it's all hydrogel, it doesn't work like that. If it's only hydrogel at the bottom, it works in a certain way. So, of course, there would be a patterned version of that. How do you optimize to access the most? Maybe unify the distribution or weight the distribution in a particular place because you want to control it. It's this kind of studies that I would be looking for. Okay.
Yeah.
So I'm not overly critiquing this one. I'm just trying to suggest different ways of reading it.
Yes, definitely. Yeah.
Okay.
Like we found some research about water vapor and how these bumpy surfaces like captures water. We try to simulate like the same system on Maya. I think the next slide, definitely. And like even the angle of these bumps make a difference. Not sure if,
I don't know why it doesn't play.
I'll play it quickly on mine.
Yeah.
So like it's again simulations that proves that bumpy surfaces actually directs water and actually like retains the water versus the flat surfaces. So we're imagining that again that what we presented in the mid review, those strands,
Hairy.
yeah, could have these properties like the bumpy ones, because like we don't have to add a lot of materials into the system, so that because we imagine that the system has to be really lightweight in order to float and in order to like
I totally.
But if we have like a lot of materials like hybridized too much, then how can we float it, basically, you know?
Yeah, I get it. At the same time, I think we declared one thing, which is water is our medium, right?
Mm-hmm.
So the truth is, water as a vapor, super light. Water as liquid, not so light. Water as ice, you get my point. So the interesting aspect of what you're doing has to be about, in some sense, triggering those phase changes. So, like this kind of study about making something bumpy, I would say this. I think it's very intuitive, right? Like it's clear, obviously, if you have some surface deformation that has captures, it'll capture water. Now, let's say the question of evaluating pattern and flow rate, and how much volume it actually holds, that would be the next level of actually trying to ask this question. So, for example, at the moment, there isn't a rerouting, there is some direct capturing at the site of the deformation. That's one strategy. Another strategy is, well, like, okay, how do these bumps actually work together to really capture and reroute larger flows of water, right? So, like, the goal of the little furry sphere thing that you guys had was pretty clear. In the scenario that we played out, is like those little furry feelers start to create surface tension between the fibers. The goal of that is that obviously that would start to weight and move towards the center. Now, if the center is closer to what, let's say, Tyler is showing, I can understand that as a capture of that liquid. I don't know how it's retained in what Tyler is suggesting, but if it has properties that could also then start to expand, Like, so for example, the mesh object that Tyler is showing looks like a circulatory network, but for example, if that was plasticine veins, like a venation, that would be a rigid thing. But if it was a soft meshing system, that could change its cross sections, and it could swell and it could release, and it would operate as something different. It would be more sponge-like. So even that, I think, has attributes. I know the issue that you say about light, but I think your project is not declared light and it's not declared, let's call it heavy. It's at different cycles with different motivations. It will be potentially from one extreme to another. So kind of like the farm team in one sense, that I feel like when things are growing and when things are done, then it should be actually a weighted system that comes down. When I'm looking at water and all of this stuff, it's different if I'm thinking of it in a place where there's no gravity, like in the space station, where water is just kind of floating around. And it's something very different when I'm thinking of it as an earthbound system, because that's where we're controlling the rain. That's where we're doing those kind of aspects of the project. That's why I also want to challenge the concept, and that's why I pressed Tyler on the issue of building and envelope. Because it would seem to me like there is no such thing as something that is so discrete that its unity is something more important than its collective, right? It's like, dandelions can work that way because at the end of the day, they're all seeds, and the goal of a seed is just to be planted. So if it's 1 or 1,000, the goal of each seed is the same, right? It's throwing 1,000 seeds, which is just playing on probability that 95% of them don't grow. But that's not the point of the design of the seed. Each seed is designed that if the right conditions are, it grows. And that's the cycle of that kind of system. It's not redundant in a traditional sense like human design systems, because it's not superfluous. It's basically how it deals with probability and environment. So that's my only point when it comes to these things. I don't have a problem of how you work on things, but how you describe these things now have to be not vague, because I think that's not helpful. But they shouldn't actually be very conservative either. Like, even if, let's say, for example, like Tyler called it a building, and it's not a bad thing. But to be honest with you, if I look at it from a perspective of a building, I have no idea what he's talking about. Right?
I think it was the idea of dust, like.
I totally get that. But what I mean is, as soon as I use certain language, it basically speaks to a scale that I can relate it relative to other buildings. It's not an issue even of an internal language. If it's helpful for how you guys talk about it, it's one thing. But when you communicate that to other people, you have to be aware of what does that mean. Like for me as well, when I'm looking at this, I asked you, is it by itself? Is it part of a world? If I zoom in, is it like a fractal? Do I see the same thing? That's something different. It speaks to time. It speaks to duration, and it speaks to what we mean in terms of atmosphere, because this is not common to talk about this, right? And when people do talk about atmosphere, at most they're talking about light, like light in some phenomenological perspective, which is okay, but I don't think that by itself is very meaningful in this studio. Right? Okay, sorry, keep going.
You want to keep the presentation?
Yeah. Oh no, this is the old one. Sorry. I doesn't update.
Okay, shall I share then?
Yeah.
It's good that there's so many old versions for something well, that's less
It's
than old.
amazing. Yeah. How is it? It's online. How is it possible?
No, it doesn't refresh. Internet today is super bad. Sorry.
Okay.
If you want to go to the next one, yeah, like we challenge the sailing logic in this part. Like we were discussing about how we navigate, how we control the cloud and its movement. So we were thinking about the sailing logic and whether a group of particles could also work as a sail. And the next one.
Let me ask you a question. When you guys are having these conversations, I understand sailing, I understand surface. I wouldn't call it a cloud. So I think one of the things that's kind of, I understand how you can start to think about that stuff because you're trying to say, well, how do I control these particles? How do we control them together? But the problem becomes very clear that then it just becomes an issue of a default of suggesting that those things are basically linked like a surface. So, I mean, it's visualized now as points on a surface, and it's visualized as, something that's more field oriented, but the truth of the matter is its behavior is 100% a surface, like a textile. And the reason that I would have a problem with starting from this point is that it kind of domesticates any agency that's happening between. The only thing that matters is the edge condition, the basic generic kind of properties in terms of the spring behavior between them that gives us the elasticity of the textile and the fixed points. And it guarantees that there has to be fixed points for it to actually work. And this is where everything falls apart. So I think it's good that you did it, so I can tell you don't do it.
Yeah, I think I totally agree. It is, since we like taking multiple trajectories and contradictory directions, it's good to take them in the beginning.
I think it's important to do it because it sets up a certain conversation. That doesn't mean the reason why you did it is not valid. The reason of trying to figure out ways of controlling things is important. But I would be looking much more locally. I would zoom into that and say okay, we need to have some relationships between these points and lines. And I don't think it's a problem to think as of a particle spring system. But what's important about it is that the spring system has a certain threshold and then it breaks. And the question is, can those springs reemerge if they're within a certain proximity? Because that would make this thing more cloud-like in some sense, which means like in a response to a certain kind of force or an environment, these things may passively break apart, but maybe within a certain range, they can come back together. And it would be closer to, for example, like, when at some moment you guys will walk down to Tate and there's always going to be a guy making bubbles for kids. And the difference between discrete bubbles or when bubbles are moving in parallel or proximity is that surface tension fuses them together, and you get sometimes these cloud formations of bubbles. Sometimes they break and you get smaller bubbles. Like, the point is that organization is responsive to environment. And the things that we're trying to do is to have a kind of strategy for thinking about proximity and control. But control can't be like a sailor harnessing wind energy in that sense. I can say that is a big part of the previous teams, the air teams project, for sure. Wind is the main driver. Here, for me, wind is not the driver for you. Water is the driver, and water is weighted. And even the concept of controlling the clouds, I mean, I really like it as a provocation. But it definitely means that your experiments have to take certain things. If I look at this slide, or if you click to the next one, my feeling is like, can it really be the next one? Like, where you have the weather formation. Can you click once? Yeah. Can this be our architecture, please?
Yeah, so we try to focus on how we could develop more of that idea of
First
this
image,
mapping.
this kind of stuff is closer to that, because in some sense, like when I'm looking at these flows, flow for you guys is very different, right? Flow, for example, can be optimizing water path, right? Like hydrology in some sense, which makes a lot of sense on a very local level to keep water retained. But on the other level, flow is a response to, sorry, Luca. Flow is really a response to forces of atmosphere, because a big part of what we're talking about is trying to harness things. Maybe the one thing that I would say is a little bit different from what Yuji mentioned is that it's not like our agents are just going to move to moisture, right? Like, that's a condition that's very clear on the ground. You have different degrees of moisture and it's entrapped in a ground condition. When we're looking at something like a cloud formation, or we're looking at an atmosphere and we're talking about that, it's very difficult, I think, to be able to somehow locate where moisture resides, right? That's why people are talking about percentages. They'll say, like, volumetrically in this area, there is a certain percentage of precipitation that may fall. But if you ask them, like, can you localize where that has fallen? No, they can only say plus or minus a certain amount, because it's a very generic approximation of volume over area. So when I'm looking at these simulations, I have to take a position. What actually are my agents? Of course, they're your designed elements in some sense, but what's the movement of them? Is it active or passive? Is it triggered by environment, or is it self-triggered, meaning like something that the agents themselves have agency to influence how they migrate? And we're going to say that they have agency, but I don't think that the agency is going to be driven by where moisture is. I mean, it may be the case in terms of a localized experiment, and that's where I think, like, designing a prototype experiment versus designing the system has to be somehow negotiated because there's not a one-to-one correlation. That's why, like, okay, I see a balloon, I see some idea of hydrogel and this. If I interpret that as your project, literally, I would say, well, of course it's not that. A balloon doesn't absorb water, it's just a mechanism to float something. Hydrogel by itself is also a enclosed environment, right? Meaning, like, literally, if I took that and I said that's what I'm building, it wouldn't achieve the stuff that you're trying to do simulation wise, and it wouldn't achieve the stuff that you're trying to talk about in terms of controlling larger environmental systems. But as a prototype, it may be a proof of concept of how you extract water and how it's weighted and how you can actually see that because the balloon is trying to lift something, the water is basically lowering it, and I have a visual kind of tangible simulation that's codified, which I think could be a very interesting experiment, right? So what I see on the right-hand side could be a material, let's call it experiment, that we try to realize to understand weight, to understand absorption of water, and to have a physical kind of manifestation of some of that stuff. Like you're saying, for the physical tests. But if I interpret that in terms of a proxy object in your simulations, then this is where it falls apart, right? Because then I say the balloon has to be controlled, the balloon is an agent, the balloon becomes mechanical, and it has nothing to do with the things we're trying to capture, which is the phenomenon. So yes, a lot of experimentation, but you also have to be a little bit self-critical about how you evaluate them. So it's not always resetting things. It's about saying, well, okay, we need to be able to control certain agent behaviors. What is possible in terms of techniques to do that? What do we mean by control? Is it range? I would suggest it's range at this stage. If it's completely particle with no spring strategy, it means that there is no larger attempt to organize, unless it's just 100% packing, right? So these are also conversations that I think are important to have with Mustafa, which is like, we're trying to exhibit a form of control that is very environment responsive. And that means there has to be a signaling between active and passive states. And we know that that can't just only be at the scale of the agent, because there wouldn't be any kind of collective intelligence in this. And from a practical perspective, it's like releasing balloons. They may be in proximity, but they don't have a way of coming together to self-stabilize or to do these other kinds of aspects that we know are important. So in your case, I would try to take the next steps of like those simulations, like the hair simulation. How does it extract moisture? How do we visualize and how do we actually quantify it? And can we quantify like those points? That can be water, beads of water, that could be surface tension. Can we have an understanding of what that accumulation really is? And can we equate that to a weight and see these things actually slowly? It's like almost like finding a way to simulate the water droplet, how it goes from something that's pure airborne into something that falls down to the ground. Except I wouldn't be controlling it the same way, let's say last year the dropping team would be talking about it, like some kind of aerial bombing kind of strategy that's almost military. This is something different. Control is not so much about a droplet, but the control is like, where is the volume of surface area that we want to basically see precipitation in this case. We're not talking about how it's received yet, but I think we should just focus on how we engineer clouds. There's There's one example. Keep going. I'm just going to.
Okay, and we chose this graded. We thought that we should develop further the graded atmospheric field, and we understand the scale of the atmosphere as a first step. So we're talking about troposphere, and there is a question of how high can we go, and in which altitude can we move. I guess that we don't want to go very high because we want our system to be almost passive, or to have to be able to control that easily. So the next slide, we check the water in spot, and depending on the altitude and the moisture, it moves. So in the next slide, we try to import weather data using NASA database in Houdini, and this was the example. This is the result. Is just from the data. We haven't used any map or anything. So this in this ramp, that you can see how humidity is mapped. So the red one for the very low values, and the blue one for the very high values. So it's funny because we can already see, and we can guess which part of the globe is that. And we can see the next slide. It's in between. We try to define an area just because we can do that for the whole globe, but we try to define an area that could be of interest. So as a first step, so it's between these coordinates, like 30 latitude and 15 longitude and 15 and 40, etc. And the next one, we also try to focus on this specific, we also focused on this specific coordinates. And I think it's interesting to see these different resolutions. The next one. So we also could move around these resolutions with our database. And next one, we try to think how we can handle and how we can understand this humidity data, and how through this understanding we could generate something. In the next step, so this is just an experimentation of, we are in between trying to use this as a tool. So we've not really great results in the next one. But these visualizations help to try to push or to think further of how what this data could mean for us. And the next one. Could we use that also as an initial model? Could this point of humidity be our agent itself, for example? Could that be an initial point for our cloud simulation, or for our swarm, if we just select, for example, only the white particles or the blue particles?
One of the things is that codification is information, right? Now the question, what is the information? What are we looking at, and why would we select white instead of red? We need to be able to make those kind of equivalents in terms of how information is part of your system. So when I say to make like your project more like a weather system, is because a weather system is not just mapping, it's also generating a probabilistic understanding of what that real-time information is, right? So if we see a certain pattern, we can understand that pattern in relative to like other forces that are coming. So temperature variables that we see that are impacting, we know if those temperature variables are within a certain range, we get rain. Or a cold front, warm front hit together, we see that they're on the path to probably coming together, in a day or two from now. We know, well, actually later in the week, There is a probability of snow or rain or these kind of things. So I think it's interesting to think that control can be mining that world as well, right? The issue that I think is important in terms of your architecture is either triggering some of that and harnessing it. So the idea of harvesting, harnessing, those things are very important. The idea of using that as something that can be triggered and mobile, those things are important. The more that you can work with the environment, the better it is, obviously, because it has more scope, more range, and it also pushes the project into new territories, which, like, I think that this becomes interesting as a model. Now, to be honest with you, if I see it in 2.5D or if I visualize it as a complete particle field, is one better than the other? I'm not sure yet, because I just need to understand what it is that I'm looking at and how do I want to use it. If I see it as a piece of information and I use computational logics or machine vision logics to push that world further, I think we get closer to trying to also invent new techniques for this kind of project, right? So that this is, for me, much more interesting than Philip Rahm kind of just doing some artificial gradients to talk about temperature, right? Like I said, I like his work in concept. I hate it in practice. And I hope that that's not too strong for me to say that, but all of the things that he talks about, I think is very important. The way that he goes about his architecture is so literal that I find it problematic. I don't know if you guys saw his lecture. I didn't get a chance to do that, but he gave a talk at the AA. I think I sent you guys the link. He was talking about politics and things like that. I didn't watch it, but I read the brief. It may be useful to watch it if you haven't. But anyhow, I think these kind of techniques, and I think Houdini is definitely the software that we need to really push for a lot of management of these kind of bits of information. But I also think it has to be taken beyond, let's say, photogrammetry and this kind of ways of transforming things. So see
Yeah,
it. Sorry, go ahead, Deb.
no, I agree. This doesn't say something yet as itself. So, but what we wanted to say here, for example, is that we can use the attributes to influence something. So here we just influence position. This is just influencing the attribute of humidity influences position. In the previous one, it influenced scale. This is a demonstration. We don't know how. I don't know how.
Let's put it this way: we may not know how, but I think it's a trajectory worth exploring, because it's not difficult to understand that it would have a meaningful influence if we can use more real-time data in our models, right? It's very different, and this is where, like, working from an image is one thing, working from a data set is something different, but it's also where I think a lot of this stuff will end up going, which is like, how do we make more intelligent use of things that are in real time? Like, the argument for the studio is real time. I mean, it's not an issue of future, it's not the issue of the past, it's not the issue of technique, but it is about this kind of information. So I think we definitely should be pushing in this direction. The question is, how do we interpret what it is that you're looking at? So first it'll be more technique oriented, but then the next thing is like, how do we plug this in? For example, you're developing some sensing technologies, and you have a live model in Houdini. The variables that we may be changing locally in a sensor would be interesting to see how that would be influencing the field of particles in this map, right? So for example, this may be a humidity data of an existing moment in time without any agency of your system influencing it. But you can imagine localized your particles are swimming in that space as well, and how does that sort of operate, and how does that trigger a response, and at what scale and magnitude? So those things can also be important, right?
Yes. And this is also not real-time data right now, but if you could, but it could be, of course. I mean, this is just a still image because in the previous one, because it is for one moment, and we didn't want to crash our computers yet. But we can we can translate that into real time.
I would say multiple. I would focus on the still image and take maybe 3 or 5 images as a sequence, so that time potentially is a consequence of that. But I think the issue of the translation is like, what is that information? How do we extract meaning from the color codification? And how does that influence maybe other forms of simulation? So, go ahead.
Sorry. Should this be the brute force of our system? Should this be considered as the parameter, the brute force of the system, or it could be the same, the system? So in a way that this becomes a cloud, data from this.
Yeah, I think the thing becomes something like this. What you're showcasing is a map, right? So you get the Borges problem of working at the scale 1-to-1 with the world, right? I don't know if you know the story of the cartographer, but the cartographer kept drawing his maps, and he basically said the only real way to draw the map of the world is to draw it 1-to-1. And the problem with drawing everything 1-to-1 is that it's not a map anymore, it's the world. So in this instance, the thing that you're extracting is scaled. The implication of how you utilize that in terms of your smart dust system at some moment will also be scaled. Now, it doesn't mean the scale of a machine, but it does mean the scale of magnitude of what you're doing. So I'm not sure yet, like we're going to try to, create a thunderstorm over Ethiopia or something like this. I'm not saying that we shouldn't. I'm just saying, there's nothing to suggest that that's what the project is yet. So I think we leave that open in a sense and really try to see how we're extracting information and how we can localize that through color mapping, and how color, if we zoom into that now, can give us a testing scenario of particles that could be more animate. So instead of starting off with something that's totally random, you start from something that is one moment in time. Let's say, 2:52 on a London evening. So yes, it is situated in the world, and it also means that it's not uniform, because this color codification also shows that if it was about precipitation or any of these things, but in that particular area, we have difference. If we zoom into that image, it'd be interesting to see what difference is still meaningful. Like if we localize that to a square block in London, for example, or a square block anywhere, that would be in a range where we would still feel some of that atmosphere if it rained, 100 feet from us. It will change the moisture in the air. It would, so there are different kinds of effects. So I think that, I think you understand what I mean. So yeah, I would keep pushing on this, and I think Houdini is definitely the platform that in your project we should get much better grasp of. I would say become a bit more expert in, because the same with the meshing operations and all of these things, it's able to manage some of this stuff better than Maya, let's say. In the past, when we were doing some of this stuff, there was a software called Softimage. This was a long time ago, but it was bought out, and I think it became part of the back end of Maya, but most of the properties that were really important in it, in terms of particle management, were removed. So, That project that I showed you, the Sweatworks project, or I showed the Earth team, I don't know, but all of that kind of really dynamic calculations of all of those sand particles and stuff like that, that was only done in Softimage. You could never do that in Maya. You could only do kind of generic meshing moments, and you would kill your computer. So I think that's good. Do you guys know this artist, Bernd Schmidt?
Burn?
Yeah, I can't say his name right, so he's Dutch. But this guy, he's interesting from the perspective that he's famous for doing these photographs of basically like pictures in a gallery, and you have, you know, these seemingly constructed clouds just floating in space. And the way he does that to keep it all there is by changing the moisture around the clouds. And that's how he pushes out vapor, and he's basically spraying water pellets around it to be able to capture something for a moment in time. And he has this video called Making Clouds, where in some sense he's talking about capturing the clouds.
I'm really interested in work that kind of exists between reality and representation in a way that it doesn't really function in the end. So as for the clouds, they're just there, they're building up, at the same time they're falling apart.
And sometimes the way he speaks about it is not bad.
So afterwards there's really this document of something that happened on a specific location. That's what counts. The idea of a cloud inside of space and the meanings people project on it.
You see all of this stuff, and at the end, you know, you get basically sometimes moments where you just see this quite beautiful cloud that's just kind of in these random spaces. This is very much about representation, but I think he became quite famous because the question is like, you know, I mean, we do stuff with atmosphere all the time with my brother, but you know, like in this image, you see where all the smoke is coming from, but it's not so clear because dissipation doesn't work like this. So to capture it, his trick is basically putting humidity in those portions so that the cloud basically forms within something that looks like a cloud in the center of the image. So with humidifiers and stuff like that, he's changing the water content in the air. So that's an interesting technique in the back of something that's just trying to create something like, a photograph. But some of the images, I think, are kind of quite compelling. And I think some of the technique is not bad when you think about a strategy for doing maybe some of the physical experiments. Anyway, just something to think about. Okay, we're good.
I have a little bit concern. Like, I know we are dealing with real-time reaction and the strategies, but if we need to turn this into architecture, so like I'm a bit confused about the purpose. Like,
What's the purpose then?
I mean the purpose for architecture, because like we need what kind of functions, and like we need to have a goal for the design.
So tell me, what's the goal?
For now, I'm thinking like we are setting this to absorb water and transfer it to the place where need water and lack of water. So that's our goal.
Okay, that sounds good to me.
Okay. Okay.
And the question is, are you doing that with large pipes and pumps? No.
Mm.
Are we trying to do something where we're thinking about architecture and infrastructure being closer together? Yes. Is it just about moving water? No. But is an important part of being able to harvest water when you don't have water? Absolutely. Because it doesn't really matter how cool of a building envelope you have. If it's in the middle of a place that doesn't sustain life, then nobody can be there.
Yeah, that's
So
true.
the concept of function, I think, is very clear, and I don't want you to get confused with that because it's really primary, actually. There is no architecture without human,
Mhm.
no human without water. I don't want to be so stupid about it, but it's really like that. I mean, human civilizations have to be driven by infrastructures that sustain that. And climate and ecology are changing, and they're putting lots of pressures because architecture is thought about in a way that is very separate from that world. So when we're trying to construct a cloud or any of these things, we're trying to construct the phenomenon to capture and build a foundation of water. Otherwise, you know, otherwise we will always have the same problem. You build towards the edge of water, but we have flooding. Or you build towards in the middle of the desert and you try to make a completely artificial environment to pretend like it's not, a futile battle with things, right? So you can evaluate cities like Dubai, you can evaluate all kinds of developments, the history of uh, urbanization in most of America. Like, there is always an artificial environment, but it has actually nothing to do with the actual context. And it creates really an amazing dependency on electricity and fossil fuels and all this other stuff, which is really not sustainable. So I want you not to get lost in like cloud talk. I want you to really focus on the fact that it is actually very, very important and architectural. All I would say is it's not architectural in the way, like you mentioned, envelope. But I wouldn't shy away from thinking about it as a breathable building in some sense, right? It doesn't have envelope like inside, outside. It's a deeper relationship to space. And it doesn't mean that somehow this is just about getting water somewhere. Of course, we're going to design the way that this is embedded within the architecture, meaning the proper way of thinking that this is somehow also where humans are part of it, right? So we have to think about those elements, but I think you also have to keep in mind how is this a piece of research? At the moment in the DRL, there's not a lot of research. I have to say that this for me is not good because it basically makes people shopping like, oh, I want to do this, so I learn a couple of techniques in Maya and somehow I do something interesting. This is pointless. The same goes to concepts of building, concepts of intelligence, or any of this stuff. We need to understand that architecture is a bit more complex than all of those things. And architecture is more than making a building. I really hope you give me the opportunity to let you understand that deeper. So I don't have a problem with you wanting to do a building. Actually, somewhere inside of me, I think that that's very important. But I don't want you to do a building that you know, because it would be really against these things, because it would be, in some sense, superimposing something else. And it's the same thing like when we were looking at the surface patterns of some of the references that you guys showed last week before the presentation and so forth with the surface patterning. So, of course, parametric patterns and things are going to be important, but how we use them is more important. So it's the same thing when I mentioned to Ulla about the bumps on the surface. Yes, bumps on the surface we're all going to agree you're going to be able to capture some moisture differently. How much moisture? What does it do when it's actually captured? All of that stuff is important. That's what I want you guys to be designing. So I want you to design as much as you can. I want you to use the simulations to give as many options as possible, but I don't want you to become super conservative. There's no research in that. And you came to the design research lab. So if it was just called design lab, maybe I still wouldn't like it. But design research means we have to experiment and we have to try things. And that means new tools, and that means new approaches to thinking about relationship to environment, and new techniques that have to be invented. So please have as many doubts as you possibly can have, but don't let that keep you from doing things. I still would like to see a building like your background.
Okay.
I think, Tyler, you would like it too. So as much as you want to do a tower, and maybe in the future you will design a crazy tower with parametric louvers, I still think, to be honest with you, you're going to do it different.
Okay.
There's before you met Theo and there's after Theo. I promise you, after Theo will be different.
Yeah, sure. Yeah, thanks.
Okay, Tyler. Okay.
Okay.
I think, yes. Bless you. Did you want to say something? No? Okay.
No.
So we move on to the next.
Can I ask a question?
I need it in the atmosphere, so.
Yeah. Sorry. Okay, yes, I think if we agree on the infrastructure architecture, we will try to move to this direction and take the correct steps further. So is the assumption that we divide our work in two scales good? Like we have the agent scale and the cloud scale. Should we move further like that? Or we should focus more on the cloud scale with this data? And the other question is like regarding if we keep this distinction and we work in these two different levels, in the agent scale, we should start with the agent, like taking, we should start like with the agent that we had the previous time and developing further on that. Does this?
I would say this. Your first slide said 3 scales, right?
Yes.
Great. I like the number 3. It's better than 2.
Yeah, me too. But so it's difficult to work in 3 scales in parallel. So we can start from 2 and challenge the third one further later, no?
You can do that, but I think the reality of the stuff is that I would say it like this. You need to focus less on scale and more on what's happening. So harvesting is happening at a local scale. Organization of what you do with that water is happening on a middle to larger scale. The larger scale is the most relational towards the environment. The local scale is the most relational to the medium of water and phase change. So it's really about understanding those things, because yes, 2 scales is fine if we say cloud versus, dust. And, when I try to prototype the dust, I'm trying to talk about phenomena. And I'm trying to simulate the hairs and extracting the water. I'm trying to talk about harvesting, but not retention yet, until I introduce the porosity and all that stuff. So I think you can keep the 2 scales, and I would say I would introduce some phenomenon experiments. So I like the idea of the balloon hydrogel physical test. I would say like 1 or 2 people can enjoy having some fun doing those things. not for the next 4 weeks, but at least for the next 10 days. And yeah, I would see it like that. I think we need to have a convincing argument for harvesting. We need to have simulations that show that. We do need to have some larger scale where we have not just a single piece of dust with some fur on it, or 5 or 6 or 50 of them, but let's say 5,000 of them, and how they're codified, how they're weighted, and treat that like as a prototypical chunk. It is just relational. It's giving me a detailed view of all of that stuff and where the water goes and how it lowers itself or raises itself. And on the global level is like, build me the clouds, show me the weather system, show me how it's relational to the environment. If we can do a bit of each of those, then I think we have a successful phase 1, with obviously a lot of things to do, but we're communicating our argumentation of infrastructure, our idea of sustaining life through the concept of water harvesting, the notion that it needs to be a mobility infrastructure to be able to respond to need. So it's not something that's planned and then has no ability to adapt, but we're designing from the beginning an adaptive system that is more ecological through its ability to extract, life-saving kind of resources from air, from those kind of things. Right? And then, like how we live with this architecture is going to be different. So just the same way you show me the textile and what that means that's deployed in the center of a village and it's used as a water pump, but instead of a pump, it's a textile. We're going to talk about how this is distributed on the ground for people to use. And what does that mean? So it shouldn't be something that's totally separated. But I think it's too premature to talk about that. And it just becomes science fiction when we don't know actually how do we extract and move this stuff. So I think that's what I can offer right now. Okay.
Yep.
And I'm going to let the next team present before it gets really, really super late for some. And yeah, just to keep
Thank you.
the conversation going.
Thank you.
Thank you.
All right, guys.